Hello again, algebra students. So right now we're going to be looking at not just shifting our curves, we're going to be shifting and flipping, so combining our transformations together. And we're going to look at more than just parabolas. So first let's take a look at our absolute value graph. And so we know that it's linear on both sides, f of x equals the absolute value of x. And each slope, the slope on the right side is positive 1, the slope on the left is negative 1. So whatever we go up, we're going to go over, and in both directions. So for the first graph, it says to flip vertically. It's just giving us a description of what the transformation is going to be. So we can actually even write an equation for this. So if we're going to flip vertically, that means we're going to have a negative outside the entire function. So to write that in equation form, we would write it like that. Now to show the flip, the vertex is going to stay where it is. That's on the axis. Whatever's on the x-axis doesn't move. So we're going to keep that where it is, and then each of these other points we're just going to flip down. So this is up 1, we're going to move it down 1. This one's up 2, it's going to be below by 2. So go ahead and draw in your flip. Maybe use pencil, so that way if you need to fix it, you can. Pause the video if you need to. Okay, so then this is what our vertical flip is going to look like, and you can see each point hand plotted, and you should also use a straight edge. Now it says to graph each of the transformations based on the most recent graph. So we're not going to use the original graph anymore. We're going to use our previously flipped graph. We're going to shift that 4 spaces up. So I'm going to take this vertex here and I'm going to move it 4 spaces up. And every other point is going to follow. Okay, so you can double check your work there. And as before, pause the video if you need to. All right, and just like before, we can write an equation for this. Our previous equation was y equals negative absolute value of x. Well, now we're shifting up. So that's going to be on the y side. We can say f of x or y minus 4 to show the up versus down equals the absolute value of, or negative the absolute value of x. Okay. And that's a y direction shift, so that's why it's near y. Now we're going to take that same graph, we're going to shift it to the left 2 spaces. So that's our x direction. So we're going to take this point up here, the vertex, and we're going to move it 2 spaces left. And then every other point from there is going to follow. So I just have these 3 initially. I'm going to go left 1, down 1, right 1, down 1 from there. So after I've moved that one, then I'm going to move all the others from there. So go ahead and draw yours. Pause if necessary. And then you can double check. Again, if we wanted to write our equation, this 2 spaces left is going to happen inside our absolute value. Those absolute value bars act as a grouping symbol, just like parentheses. So to the left, it's going to be near x. And so we're going to say plus 2 because it's shifting left. We always do the opposite of what we think. But everything else is still there from before. That's the only change. Okay, so we did flip and shifting with our absolute value curve. Now let's do some flips and shifts with a parabola, a square function. Okay, so our initial equation is f of x equals x squared. And remember, we have all of these ordered pairs. They're perfect squares. We're going to use those points and flip and shift them. So this time we've got a box for each transformation. What you're going to do is you're going to write in what's happening each time. Okay, so for this first one, we're saying f of x equals negative x squared. So that negative acts as a flip. Okay, so it's flipping down. It's outside any grouping, so it's flipping in the y direction. So what we're going to do is we're going to flip each of these points. So go ahead and draw in your new curve, this curve, but flip downward. And hopefully, if you needed more time, you paused the video. Now what we're looking at is f of x equals negative x squared minus 1. So in terms of the transformation, remember, sometimes it's easier to move the minus 1 to the other side. I like to do that. So then I can really think about what's happening. So now it's still flipping down because of this negative, But this plus 1 over here, or if you're looking at the original equation, the minus 1 on this side, that's a y direction shift. So I'm going to, after I flip down, I'm going to shift in the y direction 1 space, because it says plus, I'm shifting down 1. And that's from my previous graph. So I'm going to take this exact curve and I'm going to move it down 1 space. So I'm going to start with my vertex and move every other point from there. Okay, so we can see it's an exact copy, just shifted down 1 space. Now last, I've built in a little bit more here. And so again, I'm going to rewrite the equation with this minus 1. I'm going to add it to both sides and move it to the other side. It's easier for me to look at that way. So I've already done my flip down, that's the negative sign out here. I've already done my plus 1, that's shifting it down 1. Now I have x plus 2 inside the parentheses. So when we do the opposite, this is in the x direction, so I'm shifting to either the right or the left. Because it's plus, I'm going to shift to the left 2 spaces. So I'm going to take this curve that I've already done and I'm going to move it left 2. Again, if you need more time, make sure to pause the video in between and draw these very carefully. Notice all of the points that I've moved over with it. You're moving each of those points each time. Okay, now we're going to get trickier. So now we're going to be graphing an entire equation. So what we did on the last one is I gave you each step along the way. So what we're doing now is we're basically starting with the ending. And we're going to break that down into, well, what would the parent graph have been? Over here, if we take away all of the addition and subtraction, any negatives, we're just left with f of x equals x squared. So on the next page, when we're looking at this, we first need to look at, well, if we take away all of the addition and subtraction, take away the negative sign, what's the parent equation? And that parent equation would be y equals the square root of x. So that's our square root function. And if you need to, look back a few pages to your library of functions to graph that parent graph. Remember to plot each point very carefully. So pause if necessary, but you're going to plot the parent graph y equals absolute value of x. Y equals the square root of x. Okay, so notice I have these 3 points very, very clearly marked. So I have 0, 0, 1, 1, and 4, 2 marked in here. So even if you don't label them with ordered pairs, as long as the points themselves are really bold, so you know exactly where they are, that's going to be very important. So the next thing that we're going to do is we're going to build into our equation. And my recommendation is always shift last. So do your flips next. It's going to be a lot harder to flip once it's shifted. So in the next part, I'm only going to add in the negative in front of the square root. Okay, so that transformation is I'm flipping, since it's outside the grouping symbol, I'm flipping vertically, so I'm going to flip it downward. So I'm going to take each of these points and I'm going to flip them downward. So even if you're not marking the ordered pairs in, which I would recommend, you're at least drawing very bold points at each one of those. So now we can build in one of our shifts, and it doesn't matter which shift you choose to do first. So I just happen to do the y shift next, and you can write your equation either way, whether you put the minus 2 at the end like this, or on the other side. And so take a second to think about what that transformation is in words and write it down. Hopefully you wrote that you shifted down 2 spaces. So now I'm going to take this previous graph and I'm going to shift each one of those points down 2. And I have to apologize, I just noticed that I forgot to include the negative signs in my points here. So if you just copied down the points, make sure you fix these. This point is still 0, 0, but this one is 1, negative 1, and this is 4, negative 2. So I've shifted each one of those down 2 spaces. So correct your graph if necessary. And finally, we're going to include the minus 4. You can rewrite your equation, and I like to have the plus 2 on the y side. So now what that shift is going to be, take a second to write it down, pause if necessary, is we're going in the x direction. It says -4, we do the opposite. So we're going to the right 4 spaces. So we're going to take each of these points you previously drew and shift them to the right 4. You're going to run out of room, and that's okay. So I just marked my last point off the grid. I just counted out how many spaces that would be, so that way I could really see more of the graph. Okay, so we've now flipped and shifted to graph the entire equation, which would have been really complicated if we hadn't broken it down into parts. And that's the whole point of doing these transformations, make it a little bit less complicated. All right, finally we're going to look at an exponential curve. Remember, I've been calling this the ballerina curve. And so for starters, if you look at your equation, if you break everything down, the one thing that we can't remove is this 2 as the base. So that's still going to be the base of our exponential curve. But everything else can be removed for the parent graph. So that's our exponential graph. And when you're thinking about plotting the initial points, you can plug in using a little t-table just for y equals 2 to the x. So looking at y equals 2 to the -2 initially. Well, remember from your rules of exponents that that's the same thing as if you move it to the other location but make it positive, 1 over 2 squared. So what we're really graphing there is 1/4. We can do the same thing with -1. 2 to the -1 is 1 over 2 to the 1, which is 1/2. Then the rest of the points are pretty straightforward, right? 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. So I'm going to start by plotting each of these points in and making them nice and bold. Okay, I'll explain what the little plus sign is later. But you'll notice that there's this dashed line I've drawn in here. And no matter how small our x's get, when we have negative x's, it doesn't mean we have a negative value. We're going to keep positive values. They're just going to get smaller and smaller and smaller and closer to 0, but they'll never get to 0. So what I've drawn in here, this horizontal dashed line on the x-axis, is called an asymptote. The p is basically silent. And what an asymptote is it's a line that we approach but we don't cross. And so we'll include that in each of our transformations. Okay, so next, let's do our flip. Okay, so I'll show the description of the transformation first. So go ahead and try to write the equation of just the flip from here. Okay, how did you do? Hopefully you put the negative in front of the 2. So what we're going to do is we're going to flip this entire thing. So all of these points, you're just going to change the sign on the y values. The x's will all be the same. Okay, so you can double check your graph, make sure your points are nice and bold. And I recommend having the ordered pairs drawn in or labeled in because it really shows you what you're doing. Now we're going to get into some shifts. And so here's where I'll explain this little plus sign. So right now we have our points in relationship to the origin, which I've drawn this little plus sign in. But when we do our shifts, I'm just going to move that plus sign and the asymptote if necessary. So we're going to start with our y shift. And again, I moved the 1 to the other side to make it a little bit more manageable. And so we're going to call that a transformation of shifting up 1. Now here's what the plus sign will do for us. Every point that we have here, we're going to move in relationship to that plus sign. So I'm going to take this point that's 1 below the plus sign, I'm going to move it up 1, so it's going to be where the plus sign was. So I'm going to take the plus sign first and move it. I'm also going to move my asymptote up 1. Because everything on my graph is shifting up 1. So everything on my graph is going to shift up 1. So see if you can draw it in before I do, and then compare yours to mine, and I'll explain it once I have it drawn. Okay, so as you can see, I moved the plus sign up 1. I moved the asymptote up 1. So it's still a horizontal line, but now it's going through 1. And so this point that was at -1, -1/2, it's moved just one space up. So now it's at +1/2. The point that was at 0, -1, it's still 1 below the plus, but now that's at 0, 0. The next one was 1 to the right and 2 down from the plus. It's now still 1 to the right and 2 down from the plus, but that's now at 1, -1, and so on. So correct yours if necessary. Okay, now we'll add in the last part of our shift, and that's this +4 in the exponent. Okay, so name what that shift is doing. 4 spaces in what direction? Hopefully you said to the left. So what I'm going to do is I'm going to move my plus sign from here 4 spaces to the left, and then all of these points will move in relation to that plus sign. Go ahead and draw it in. Use pencil. This time, try to think, is your asymptote going to move if you're shifting to the left? Okay, so the answer to that last question was no, it doesn't move. Because it's a horizontal line, it goes on forever. So when you shift it left and right, it doesn't show any movement. So it's already been shifted up 1. But what does move is that plus sign. It's moved 4 spaces to the left. And then each of these points in relationship to that plus sign have also moved. So all I did was I subtracted 4 from each of the x values. But the y values haven't changed. Okay, so now we have done some shifting and flipping with a couple of different types of our library of functions. And like I said before, it's always best to flip first. It makes it a little easier. If you try to flip last, it's really hard.